guys, for today's video, we will be discussing another methods of solution for higher order differential equation. So this time around, we will be considering non-homogeneous equations. So particularly using the method for undetermined coefficient. So we can recall that non-homogeneous equations are equations, okay, which contains the dependent variable, so together with its derivative, and on top of that, so there is another function, so which is the g of x. Okay, so the presence of the g of x on this given differential equation, so that makes it as a non-homogeneous differential equation. And in finding the solution for non-homogeneous equation using undetermined coefficient, so there are two things that we must do. Okay, so the first one is we find the complementary function yc. So the complementary function is the solution for the homogeneous part of a non-homogeneous equation. Okay, so the equation, so which involves the dependent variable and its derivative. So once we solve it, so it follows the same format, or it follows the same formula, so for homogeneous equation. So we classify them according to the three cases. So for repeated roots, for distinct roots, or even for complex roots. And once we found the solution, so that makes it as our complementary solution yc. And then so for our particular solution, so yp, so this is different from the particular solution whenever we are solving for the initial value of a given differential equation. So this time around, so we have the particular solution, so which is the solution for the g of x. Okay, so for the g of x part of the non-homogeneous equation. And using the superposition principle, so we can get the general solution of the differential equation as a combination of the yc plus yp. So y here, so would correspond to the general solution, and yc plus yp, so that would be the linear combination of the complementary function yc and the particular function yp. Okay, but take note that not all of the function of x can be solved using undetermined coefficient. So there would be a limit, okay, so in solving or in using the methods for undetermined coefficient. The first consideration would be the coefficients are all constants. So that means we can only solve constant coefficient. Okay, so we cannot solve variable coefficient using this method. And at the same time, so g of x is limited to certain functions. So first, g of x could be a constant. Okay, so g of x could be any constant. So g of x could be a polynomial function or an algebraic function. So it's a polynomial function or a constant, so that would be possible for undetermined coefficient. So similarly, exponential function can also be solved using undetermined coefficient. And then for sine function and cosine functions, so can be solved as well using undetermined coefficient. But it's not for all trigo functions. So it's only limited for sine function and cosine function. And lastly, g of x can be a combination. Okay, so it can be a combination, a product of two of these functions, or a sum and difference of these functions. So again, so we are only limited with polynomial functions, we are limited with exponential functions, and sine and cosine, plus of course a combination of those functions mentioned. So whether those are in terms of a product or a sum and difference of those functions. So now, for us to solve the particular solution, so there is a table that we will be using. Okay, so the table is for the trial particular solution. So it depends on the format of the g of x, so that would tell us so what kind of trial particular solution are we going to use. So as you can see here, so number 1 to 4, so those are polynomial functions. So 5 and 6, so those are sine and cosine function. And the number 7 would be an exponential function. Okay, so for for the algebraic function, so we have to take note of the degree of the polynomial, okay, or the highest exponent. Okay, so the highest exponent. And when we are enumerating the terms of the trial particular solution, so it should contain all the terms. Okay, so whether it is present on the g of x or not. Okay, so for example, if I would have, it's just a constant k, so that means my trial solution then, so yp, so will be equal to 8. Okay, so that is for constant. Okay, so if it is 5x plus 7, okay, so let's say that is a polynomial, so with the 5x plus 7, so then, so we'll have ax plus b. Okay, so we have ax plus b for our trial particular solution. But then there are cases like, for example, this, we have 3x squared. Okay, so 3x squared minus 2. So the highest exponent here is 2. Okay, so x squared. The high exponent is 2. So we need to complete the entire terms. Okay, so starting from 2 until it becomes constant. Okay, so we start with x squared, then followed by x, and then followed by c. Okay, so it doesn't mean that we don't have an x on our g of x here. Okay, so it's just 3x squared and minus the constant. So we don't have the coefficient for x. Actually, it's the coefficient there is 0. Okay, so it was not just written. But then for our trial particular solution, it should contain everything. Okay, so from the highest derivative or highest exponent, so up to the constant part. So the same is true with this one. So for the fourth one, so it is missing, or x squared is missing. Okay, but then, so when I write the particular solution, so it contains everything. So ax cubed plus bx squared plus cx plus e. Okay, so that is for the algebraic functions, okay, or for polynomial functions. And then for sine 4x and cosine 4x, so remember, for homogeneous equation, so when we are solving for case 3, so usually, if we have a complex roots, okay, so complex roots, so which has this format, the alpha plus and minus beta I. Okay, so alpha plus and minus beta I. So when we are writing the solution, okay, so for this particular case, so it's always a combination of the sine and cosine function. Okay, so it's always the combination of sine and cosine function. So that means in complex roots, so they always come in pair. Okay, so it's not possible to just have the positive part of the imaginary number and then missing the negative. Okay, so it always comes in pair. So if there's a positive beta I, so there will be a negative beta I. So that is why, so for our particular solution, so let's say we have sine 4x. So when we write our particular solution, so even though the cosine is missing, so it should always appear on our trial solution. So in this case, so we just copy, so sine 4x, so that's just what's important there. So it should contains the sine 4x and the cosine 4x as well. And then we attach a and b for the coefficient. So similarly, so if we have cosine 4x, so missing the sine x, but then when we try, or when we write our particular solution, so we write both the sine function and the cosine function as well. So we copy the function as is, so sine 4x and cosine 4x, and then we attach a and b as the coefficient of those two functions. And then lastly, for number 7, so we have the exponential function e raised to 5x. So in this case, so we just multiply. Okay, so we just multiply our coefficient. Okay, so that is just 8. So for numbers 8 to 12, so this is a combination, okay, or a product of functions. Okay, so it's a product of functions. So for number 8, it's a product between algebraic function and exponential function. So in this case, so we follow, okay, so we follow the rules from 1 to 7, and then we just multiplied it, so wherever it is multiplied. So in this case, so we have the highest exponent here is 1, so for that is for x. So therefore, so we have ax plus b, and then multiplied it with e raised to 5x. Okay, so the highest is 1, so therefore we have ax there as well. For number 9, so it's a product of exponential function and polynomial, okay, so x squared. So but then here, so since the highest is 2, So it should contain x squared up to the constant c. So in this case, we'll have ax squared plus bx plus c, and then multiplied it with e raised to 5x. So number 10 is a combination of exponential function and sine. So we have sine for x, as I mentioned a while ago. So if there is a sine for x, so there should be a cosine as well. So we start with sine for x and cosine for x, and then it is multiplied with e raised to 3x. So it should contain e raised to 3x as well. And then I would just have attached the coefficient a and b. So if it is algebraic and sine function, so again, so sine for x, so there should be a sine for x there and a cosine for x on the other part. And then since the highest exponent there is x squared, so I should list down everything. So ax squared plus bx plus c, then plus ex squared plus fx plus g. And then lastly, so it's a combination of the three. Okay, so we have the algebraic, exponential, and the cosine function. So again, so e raised to 3x sine x, so e raised to 3x cosine for x should be there. And then since this is x, so there should be ax plus b and then cx plus e. So that is how we use this table. Okay, so it just depends on what is the g of x. So take note, if you have noticed here, so we're not using the letter D here. Okay, so it's because some books uses this D as a notation for derivative. So remember, so if we have, let's say, D cubed, or actually this is the third derivative plus the first derivative of y. So this is a notation that is used for derivative. Okay, so to differentiate it from it's used here as a constant. We're not using D. Okay, so for our letter here. Okay, so that is the table that we're going to use. Okay, so for in finding the trial particular solution of a non-homogeneous equation using methods of undetermined coefficient. So if the function is not listed on this table, then that means this method is not applicable for that type of equation. So now let's proceed with the cases for method of undetermined coefficient. For homogeneous equation, we have three cases. But for undetermined coefficient, so we have two cases. So the first case and the second case. So in solving, okay, so in solving for the for non-homogeneous equation using undetermined coefficient, so there are two solutions that we will be getting. So that is the complementary solution and the particular solution yp. So let's say we are given a complementary solution. So let's say that would be c1 e raised to x plus c2 e raised to negative x. And then so based from our table, so let's say the g of x here is equivalent to e raised to 2x. Okay. So therefore, the trial particular solution for that, so since that's just an exponential function, so we copy e raised to 2x, and then I'm just going to attach a here. So in determining, so what case are we going to use for undetermined coefficient, we compare the particular solution to the complementary solution. So in this case, so how do we compare? So we look at the term. So in this case, our particular solution is e raised to 2x. So we're going to take a look at complementary solution if there is something that is common. Okay, so that means the two terms are similar, okay, so with each other. So this is e raised to 2x, this is e raised to x. They are not the same. Okay, so those are different. So similarly, e raised to negative x is not the same as a or e raised to 2x. So if we cannot find a term on our particular solution, so which is a duplicate of the term from the complementary solution, then that makes it as a case 1. Okay, so that makes it falls under case 1 for undetermined coefficient. So meaning there's no duplicate solution, okay, so for the complementary solution and that of the particular solution. But then let's say we have another one. So let's say our particular solution is the, or complementary solution is this. So C1 e raised to x plus C2 e raised to C2 is x e raised to x. Okay, so YC, so C1 is equals to x plus C2 is equals to x e raised to x. So this one is case 2, it's repeated roots. And then, so let's say it just so happened that our g of x here is equals to e raised to x. So therefore, if I'm going to write my particular solution here, so since g of x is e raised to x, so that would become e raised to x and then multiply it with a. So a e raised to x. So now, observing our particular solution in comparison to our complementary solution, e raised to x is the same as the first term e raised to x. Okay, so C1 is just a constant, a is a constant as well. But these are similar terms. Okay, so both of them are e raised to x. So in this case, this one falls under case 2. So meaning the term on our complementary solution is duplicated on the term for our particular solution. And we do not want that. Because remember, the solutions of our differential equation should be linearly independent with each other. So that is, the Wronskian should not be equal to 0. It's because, so for example, if I am going to do this one, so let's say our general solution is yc plus yp. So if our yc is c1 e raised to x plus c2 x e raised to x, and then our yp is a e raised to x, so I can combine the two. So c1 plus a, then e raised to x plus c2x e raised to x. But then c1 plus a is constant, so it could be absorbed by c1. It could be c1 as well. So what happens here is the particular solution is just absorbed, okay, so by the complementary solution here. Okay, so if you're going to test, okay, so the linear dependency of this type of solution, those are linearly dependent. Okay, so it will make this one equal to 0. Okay, so for the Wronskian. So we don't want that one. Okay, so its solution on the complementary solution as well as on the particular solution should be unique with each other. Okay, so there should be no duplication. So that is why if it is case 2, so what are we going to do to prevent the duplication? So this is what we did for case number 2. Right? So for case number 2, if we have repeated roots, so what are we doing? So we are attaching x for the second solution. So just like what we did here. So our solution here is, there are 2 1s for the roots. Okay, so that's why we have c1 ex and then plus c2 x ex. So this one corresponds for the second repeated roots. So that is why for this particular case, so what we will be doing is we're going to do the same thing. Okay, so if this is the same as the first term, so we multiply it with x. Okay, so a times x e raised to x. But then, so once we multiplied it with x, so we have to take a look at again at our complementary solution. Okay, so this a x e raised to x is no longer the same as this. But then, it becomes similar with the second term of the complementary solution. So that is why, so what we're going to do is we're going to multiply it again by another x. So that makes it ax squared e raised to x. So this time, so our particular solution is no longer the same as the 2 solutions on our complementary solution. So that is for case 2. Okay? So recall, so case 1, so there should be, or there is a distinct solution for the particular as well as for the complementary. If there is a similar solution on our particular solution in comparison to our complementary solution, that makes it case 2. And to make it different, we multiply it with x. But then when we multiplied it with x, so we need to compare it again with the complementary solution. If there is another duplication, so we multiply it again with another x until there will be no duplication on the two solutions. Okay? So those are the two cases for undetermined coefficient. So let's proceed with our first example. So for our first example, so determine the form of particular solution. So we have y double prime minus 9y prime plus 14y is equals to 3x squared minus 5 sine 2x plus 8x e raised to 6x. So again, so for us to determine, so whether this is case 1 or case 2, so since our task is just to find the form of the particular solution, so we're not even being asked what is the general solution, but rather what's the form of the particular solution. So we just need to classify so whether that is case 1 or case 2. So to do that, so we need to find first our complementary solution. So for our complementary solution, so we transform this one to algebraic. So y double prime is m squared, so minus 9m, and then plus 14 will be equal to 0. So m squared minus 9m plus 14 is equals to 0. Okay, so to make our computation a bit faster, okay, or actually it's up to you. Okay, so we can factor this out. So we can factor this out right away, but we can use also our calculator. Okay, so we can use our calculator to make sure that our answers are correct. Okay, so in this case, I'm just going to right away, so find for the roots. I'm going to use the calculator. So for the equation, so I'm just going to click equal sign. And then, so since this is a quadratic equation, so it's a polynomial, I'm going to press 2. And then this is a quadratic, so therefore it's a degree 2. So I'm going to select 2 as well. And then, so I'm going to write the coefficient. So for each given term, so m squared, the coefficient is 1. So I'm going to type 1, then equal sign. And then for the coefficient of x, it's negative 9. So negative 9 equals. And then for the constant, that is 14 equals. And then equal sign, so giving us x1 to be 7. And then another equal sign, so press equal again, so x sub 2 is 2. So those are the two roots, that is 7 and 2. Okay, so that is 7 and 2. If you want to factor it out, it's up to you. Okay, but as long as you were able to transform it into algebraic equation, so then we can use the calculator, so right away. So we can now write our solution then. So our complementary solution, so since this one falls under case 1, so that is distinct roots, so that makes it c1 e raised to 7x, then plus c2 e raised to 2x. So that is our complementary solution. So c1 e raised to 7x plus c2 e raised to 2x. And we're going to take a look at each term of our, so this is our g of x. So this is our g of x. So it's a combination of the three functions, polynomial function, the sine function, and the exponential function. So in here, so what we are given is exponential function, e raised to 7 and e raised to 2x. So we have an exponential function here, but then that is e raised to 6x. So which is totally different with e raised to 7x and e raised to 2x. So therefore, so this one falls under case 1. So from here, so we can now write our particular solution. So to be, so there are three terms involved here. So the first term is 3x squared. In this case, so since this is x squared, the highest exponent is 2. So we write from x squared. So that is a x squared plus bx and then plus c. So that is for 3x squared. But then for the second one, so we have the negative 5 sine 2x. So when we say sine 2x, so there should be a cosine. Okay, so that would make it sine 2x, and there should be a cosine 2x as well. So by the way, for our particular solution, everything should be positive. So although we are given a negative here, so when we write our particular solution, we do not follow that sign. So all of our terms in a particular solution should be in positive. However, so when we get already the value of a, b, and c, there's a possible that I would be negative. But then for our trial particular solution, so everything should be positive. So since we're not using d, so I'm going to add plus e, and then this one would be plus f. Okay, so ax squared plus bx plus c plus e sine 2x plus f cosine 2x. And then lastly, so we have e raised to 6x. Okay, so we have e raised to 6x. But then, so this is multiplied, so with 8x. So 8x, so the highest exponent is 1. So therefore, after f, we have gx, and then plus h. So gx plus h. So that's for the algebraic part. The 8x, so the trial solution then is gx plus h, and then multiply it with the exponential function e raised to 6x. And that is how we write this one. Or we can rewrite this as, you can distribute it. Plus gx e raised to 6x, and then plus h e raised to 6x. And that will be our particular solution. So this is for case 1. For number 2, so we are to determine the form of the particular solution. So again, so we repeat the same process. So we have m squared minus 2m, and then plus 1 is equals to 0. Okay, so we get the complementary solution first. So we can use our calculator. So for simultaneous equation, so there are, that is for polynomial degree 2. So we have 1, then a negative 2, and a positive 1. So our x, or m1, is equals to 1. And as you can see here, it will only show the root, which is 1. Okay? So it will not show the second root. Just so happen that this is a repeated roots. So for this particular calculator, or most of the calculators, so it won't show repeated roots. So that means, since this is quadratic, we are expecting that there are 2 roots there. So if there's only 1 root that was shown, so it is automatic that the second root is just the same as the first root. So that is why our m2 is 1 as well. So for our complementary solution then, so I'll just use case 2. So case C1, repeated roots. So C1 e raised to x, and then plus C2 x e raised to x. So C1 e raised to x plus C2 x e raised to x. But then, look at our g of x. So g of x is e raised to x. So therefore, our yp then, so will be, initially, so it's a e raised to x. But then, so this is the same as this. So they are exactly the same. So this makes it as a case 2. So therefore, I multiply it again, or I multiply it with x. So ax e raised to x. But this time, it's similar with the second term. So our final trial particular solution then should only be a x squared e raised to x. So if you're wondering what will happen if, for example, if I'm not going to multiply it with x, even though there is a repetition or a duplication of a function. So once you solve it, you will not get any values for the constant a in this case. Okay, so it will totally cancel it out. Okay, that's already the clue that you use, okay, an incorrect case. Okay, so for our particular solution, so we have yp is equal to ax squared e raised to x. So for problems number 1 and problem number 2, it's just determining the form of the particular solution. So for example number 3, so we will be solving this example, or we will be already finding the solution or the general solution of this particular higher order differential equation. So again, always, so we start with m squared, so plus 4m, then minus 2 is equals to 0. So we determine, so using our calculator, what is m1 and what is m2. So I'm going to write that is 1, and then I'll have 4, and I'll have a negative 2. So we'll have x1, so to be negative 2 plus square root of 6. The second one is negative 2 minus square root of 6. So when we write our complementary solution here, so what kind of, or what case will this one fall? I know what you're thinking. Okay, so you're thinking that this should be a case 3, wherein alpha would be negative 2 and then beta is the square root of 6. But mind you, it's not. Okay? So remember that case 3 is for complex numbers. Okay, so we cannot see an imaginary number here. So we don't have, that's not a square root of 6i. Okay, but rather it's just a square root of 6. So that means this negative 2 plus the square root of 6, those are real distinct roots. Okay, so those are real distinct roots. So therefore this one falls under case 1. Okay, so yc then would be c1 e raised to negative 2 plus square root of 6 times x plus c2 e raised to negative 2 minus square root of 6 times x. So that makes our complementary solution. So for our particular solution, so this is our g of x, so which is 2x squared minus 3x plus 6. So it is algebraic in nature, or it's a polynomial function. So therefore, so since the highest there is square, okay, so since the highest there is a square, so we're just going to enumerate, okay, so the solutions, so from x squared until the constant. So that would give us a x squared plus bx plus c. Okay, so that is ax squared plus bx plus c. And as you can see here, so no terms on our particular solution, so which is the same as those in our complementary solution. So therefore, this one falls under case 1. So now that we have our complementary solution and the particular solution, it doesn't end there. Okay? So we need to find what are the values of A, what are the values of A, B, and C. Okay? So to do that, so we employed the same rule in verification of solution for differential equation. So I'm going to use the original equation and then I'm going to substitute For example, for yp, so that would correspond to y. And then I need to derive it, the first derivative, so to get y prime, and then find the second derivative, so to get the second, or y double prime. And then I'm going to substitute it with the original equation. So from there, I'll be able to determine what are the values of a, b, and c. So to do that, so I'm going to find yp prime first. So yp prime, so a, b, and c are considered constant. So derivative of ax squared, so will be 2ax. And then derivative of bx, that is just b. So derivative of c, so which is constant, that will just be 0. And then lastly, so yp double prime, so derivative of 2ax, so that would just be 2a. So b will be 0. So now that I have yp, yp prime, and yp double prime, so I'm going to substitute it with the original equation. So that is y double prime plus 4y prime minus 2y is equals to 2x squared minus 3x plus 6. So we're going to substitute y double prime is the same as 2a, then plus 4. So y prime is taken here, so which is 2ax plus b, and then minus 2, our y will be ax squared plus bx plus c is equals to 2x squared minus 3x plus 6. That's giving us, we'll have 2a plus 8ax plus 4 times b is 4b minus 2a x squared minus 2b x and minus 2c is equals to 2x squared minus 3x plus 6. So now that we have all of these, so we're going to equate the coefficient of all the terms, okay? So in this case, so we equate coefficient for, so we start with x squared. So the coefficient for x squared, so this is the term that involves x squared. Okay, so this is x squared. Then this is the term that involves x squared as well. So what we're going to equate is just the coefficient. So the coefficient of x squared here is negative 2a. Negative 2a. And then at the right hand side, so that would be equal to 2. So that is for x squared. So next is for all the terms involving x. So what are all the terms involving x? So this one. So this is x. The second one, this is x. The third one, so this is x. So now, so we have 8a, then minus 2b will be equal to negative 3. So 8a minus 2b is equals to negative 3. And lastly, so all the terms that involve constant. So what are all of those? So we have this one. So this is constant, 2a, 4b, 2c. And then we have the plus 6 here. So plus 6. So now, so we write that as 2a plus 4b minus 2c is equals to 6. So these are the three equations this time. So we have negative 2a is equals to 2. 8a minus 2b is equals to negative 3. So 2a plus 4b minus 2c is equals to 6. So now that we were able, okay, so to write all the equations. So again, so it's up to you. So if you are at ease, okay, so in solving this equation, so using either by elimination method or by substitution, then go for it. But then, so since you already formed the equation, so I would prefer to just use the calculator. Okay, so and then let the calculator do the calculations. So I'm going to go back to the main menu. So I'm still going to use the equation function. So that would be equal. So a while ago, we're using the polynomial. Okay, so we're using the polynomial for finding the roots. But this time, so since there are three equations involved, so those are three linear equations. So I'm going to use the simultaneous equation, the first menu. Okay, so I'm going to click 1 or type 1. And then, so we are asked, so how many unknowns? So how many unknowns do we have? So we have A. Okay, so we have A, so we have B, and we have C. So there are three unknowns here. So I'm going to write 3 or press 3. Okay. So now, so we are given this three equations. Okay, so 0x plus 0y plus 0z is equals to 0. So that means the 0 there, or for x, the coefficient of x, so that corresponds for A. Y will be B, and then C will be Z. And then, as you can see there, so you can see an equal sign there. So 0z is equals to 0. So that means the constant part is on the right side of the equation. So similar on what is on our system of equations. So now, so I'm going to start with x squared. So we have negative 2a. So that means the coefficient for x will be negative 2. I'm going to write negative 2, then equals. And then the second one, we don't have b. Okay, so that means that is 0. I'm going to move to the second. Next, we don't have c as well, so that means that is 0. And lastly, so that will be equal to 2. Okay, so for the constant parts, I'm just going to write 2 equals. For x, so we have 8 for A, B is negative 2, C is 0, and constant is negative 3. And then for the constant part, so we have 2a plus 4b. So we have 2 for x, y is 4, and then c is negative 2, and then the constant part is 6. So now we were able to enter all the coefficients. So once we press, so the first thing there is our a. Okay. So a then will be equal to negative 1. Make it equal again. So second would be our b, so which is negative 5 over 2. And then c is negative 9. So we have a is negative 1, negative 5 over 2, and negative 9. But then remember, so what is our yp? So I'm just going to copy our yp here. Our particular solution is ax squared plus bx plus c. So therefore, yp will be negative x squared. B is negative 5 over 2x. And then c is negative 9. So that makes our particular solution. But then, so for our general solution, it's the linear combination of our yc plus yp. Okay. So our yc, I'm going back with my original answer here. And I'm going to attach my particular solution, so which is this one. So forming my general solution, so to be this one. So our general solution is c1 e raised to negative 2 plus square root of 6x plus c2 e raised to negative 2 minus square root of 6x, and then minus x squared minus 5 over 2x and minus 9. And that's how we solve, okay, undetermined coefficient or equation using undetermined coefficient. So we'll have another example. So example number 3, so we have g of x, which is algebraic. So how about if it is sine? Okay, so we go back with the equation. So we start with m squared. So minus m plus 1 is equals to 0. Going to go back to polynomial, so which is 2. Degree is 2. Coefficient of x squared is 1. Negative 1 for m. And positive 1 for the constant part. So that yields to an m value of 1 plus square root of 3 I all over 2. So in here, so we can see that our alpha, which is the real part, so which is 1/2, and then our beta, by the way, this is plus and minus as well. So I'll have plus and minus there. So plus and minus. So therefore, our beta, so will be square root of 3 all over 2. So alpha is for the real part. So beta is the coefficient of the imaginary part. So thus, we can write our complementary solution to be C1 e raised to x all over 2. Okay, then cosine. So I'll start with cosine. Square root of 3 all over 2x. Then plus C2 e raised to alpha is 1/2, so times x. So e raised to x over 2, and then sine square root of 3 all over 2 times x. So that is for our complementary solution. So for our particular solution, so yp, so since that is sine 3x, so I can make it sine 3x. I'll start with sine 3x. And then plus, so there should be a cosine 3x. So there would be A and B for the cosine 3x. So A sine 3x plus B cosine 3x. So that is our yp. Then, so that's second derivative. So we need to find the derivatives. So yp prime, so will be A. Derivative of sine 3x is cosine 3x. Derivative of 3x, it's 3. So giving us 3a cosine 3x. And then for b, so we have derivative of cosine. So we have b, and then cosine is negative sine 3x. So derivative of 3x, it's 3. So giving us negative 3b sine 3x. For our yp double prime, so we have cosine 3x would be negative sine 3x. So negative 3 times 3, so we have negative 9a sine 3x. Then sine 3x is cosine times 3. So we have negative 9b cosine 3x. So now I'm going to write the equation. So y double prime minus y prime plus y is equals to 2 sine 3x. Y double prime minus y plus y. Okay, so y double prime is this. So I'm just going to copy y double prime and paste it. And then, so it's minus for the y prime, so minus. So I'm just going to copy yp prime, paste it. And finally, so I'll just have plus y. So copy. And that will make it equal to 2 sine 3x. Okay, so let's just distribute the signs. I'll have a negative 9a, so sine 3x, minus 9b, cosine 3x, minus 3a, cosine 3x, then positive 3b, sine 3x, plus a sine 3x, plus b cosine 3x is equals to 2 sine 3x. So now, we equate coefficient. So we equate coefficient. So we start with sine 3x. So all the terms that involve sine 3x. So all the terms that involve sine 3x are these. So this is sine 3x. This is sine 3x. This is sine 3x. And this is sine 3x. And we write. So negative 9a, the coefficient. The second is positive 3b. And then the third is positive a is equals to 2. So we combine similar terms. So negative 9a plus a is negative 8a plus 3b is equals to 2. The second one, so we equate all the terms involving cosine 3x. So these are the terms. So cosine 3x, then this is cosine 3x, and this is cosine 3x. So there are three terms involving cosine 3x. So that is negative 9b, excuse me, minus 3a, and then plus b. So on the right side, so we don't have cosine x, so that makes it 0. And then we can combine negative 9b plus b. That is negative, or I'll start with a. Negative 3a. Then negative 9b plus b, it's negative 8b. Is equals to 0. Negative 3 minus 8b. Okay, so now we have our two equations. Okay, so there are two unknowns, which are a and b. So I'm going back to the equation. So on my main menu, so equation function. So it's simultaneous equation, so that will be 1. And then there are two unknowns, so therefore I'm going to press 2. So I'll start with the first equation, so which is this one. Negative 8. And then b is 3, positive 3. The constant is 2. For the second one, so which is this one, so a is negative 3. Negative 3. And then b is negative 8. And then 0. Okay, so for the constant part. So we can see here that our a is equals to negative 16 over 73. And our b will be b is 6, positive 6 all over 73. So now, so we can get our particular solution. So this is our yp. So I'm just going to copy it. So therefore, our yp then, so will be negative 16 over 73 sine 3x, then plus 6 over 73 cosine 3x. Again, for our general solution, that is yc plus yp. So y then, so I'm going to copy the complementary solution, so which is this one. And then our particular solution is this. So our general solution, so will look like this one. So C1 e raised to x over 2 cosine squared of 3 all over 2x plus C2 e raised to x over 2 sine squared of 3 over 2x minus 16 over 73 sine 3x plus 6 over 73 cosine 3x. And that is another case 1. So for example number 4. So let's proceed with our last example. So using case 1. I guess this is another case 1. So let's verify. We have m squared minus 2m. So minus 3 is equals to 0. Equation. Polynomial. So second degree. So we have 1, a negative 2, and a negative 3. So m1 is 3 and m2 is negative 1. So therefore our complementary solution is case 1, distinct roots. So c1 e raised to 3x plus c2 e raised to negative x. So for our solution, so this is a combination, okay, so of algebraic and exponential. So our yp then, so I'll start with the first two. So since these are algebraic, so the particular solution so will be ax plus b. But then, so for our second one, so it's a combination of algebraic or polynomial and exponential. So that would be plus, so 6x, so I'll have cx plus e. Then multiply it with e raised to 2x. So 6x is cx plus e. So therefore, our yp then, so will be ax plus b plus cx e2x plus e2x. So again, so since this is a second derivative, so we find the first derivative first. So that would make it a, then b is 0, then plus c. So x e2x so will be product. So u is x, e2x, derivative of 2x, it's 2. Then plus e2x, derivative of x, it's 1. So plus, this is 2e e2x. So yp prime so will be a plus 2c x e2x plus c e2x plus 2e e2x. So that is our yp prime. And for our yp double prime, so derivative of a will be 0. Then I'm going to move out 2c, so which is constant. And then derivative of x e2x, it's the same. So that would make it 2x e2x plus e2x. And then plus c e2x, so that would be 2c e2x. Then plus 2e e2x, so 2 times 2, I'll have 4e e2x. So yp double prime then, I'll have 2c times 2x, that would be 4c x e2x. And then plus 2c e2x plus 2c e2x plus 4e e2x. Or simply yp double prime, so would be 4c x e2x plus 2c plus 2c is 4c e2x plus 4e e2x. So now that we have yp double prime, so we can go back to our original equation. Y double prime minus 2y prime minus 3y is equals to 4x minus 5 and plus 6x e2x plus 6x e2x. And we substitute, so I'm just going to copy y double prime the next is minus 2 then y prime, and this is our y prime, so it won't fit. I'm going to reduce it. And then lastly, so I'll have minus 3, multiply it with our yp, so which will be equal to this one. So this will be equal to, so 4c x e2x plus 4c e2x plus 4e e2x minus 2a minus 4c x e2x okay, then minus 2c e2x minus, we distribute to 4e e2x minus 3ax minus 3b minus 3cx e2x then minus 3e e2x is equals to 4x minus 5 plus 6x e2x. So we can cancel out something here, and that is 4cx e2x is the same as this one, so minus, then 4e2x and minus 4e2x as well. So now we can equate. Okay, so we start with probably all the terms involving e2x or x e2x. So all the terms involving x e2x, so we have this one, so x e2x and this one, so x e2x. So we equate coefficient involving, okay, so x e2x first. So x e2x, I'll just have a negative 3c is equals to 6. And then second, so all the terms involving e2x. So this one, it involves e2x, and then we'll have this one as e2x, this one as e2x as well. So that makes it 4c minus 2c minus 3e is equals to 0. Or this is the same as 2c minus 3e is equals to 0. So next, all the terms involving x. So all the terms involving x, so we have this one. So we have x there, and we have x here. So negative 3a is equals to 4. And lastly, so for constant. So for constant, so we have negative 2a and negative 3b and negative 5. So negative 2a minus 3b is equals to negative 5. So that's, we can use our calculator now. So these are 4 unknowns. So I'll go back with the menu equation. It will be simultaneous equation. There are 4 unknowns. So I'll start with this one. So we don't have A, we don't have B, but we do have C, so which is negative 3. And then D is 0 as well, and then our constant is 6. For the second one, so we don't have A, we don't have B, but C is 2. And then E is negative 3. Constant will be 0. Then, so we have for the third one, so we have negative 3. Negative 3. 0 for B, C, and E. Then for the constant, we have 4. And lastly, we have negative 2. Negative 2. Negative 3. 0 for Z, C, and E. And then lastly, for the constant, it's negative 5. So we have for the values of A is negative 4 over 3. So followed by B, so which is 23 over 9. Then C is negative 2. And then the E, which is negative 4 over 3. And now, so our particular solution, so we follow this one. Or we copy, we paste it. So our YP then will be negative 4 over 3 x. B is plus 23 over 9 minus 2x e raised to 2x, and C is minus 4 over 3 e raised to 2x. And for our general solution is YC plus YP. So Y will be equal to, so we copy the YC. So YC is C1 e raised to 3x. And then, so for our YP, so YP is this. Okay, so for our general solution then, so would be y is equals to C1 e raised to 3x plus C2 e raised to negative x minus 4/3 x plus 23 over 9 minus 2x e raised to 2x minus 4 over 3 e raised to 2x. By the way, even all of the terms will interchange with each other. It's just fine. Okay, probably the arbitrary constant will interchange. It's just fine. And I'll end for the meantime, okay, so on this example, so this would be the part 1 of this video presentation about undetermined coefficient. So we limited our solutions so using case 1. So I'll proceed with case 2. So I'll have two examples for case 2 on the part 2 of this video. And that will be all. So for the meantime, okay, so for this particular topic, and see you again for the part 2 of this video presentation.